Solving this given equation will allow us to start from this equation with differential operator D, and then moving on to an auxiliary equation, solving for the roots, and then providing us with a general solution for roots involved in the auxiliary equation, which are all imaginary. So we are going to verify if the roots here are imaginary. So let's start coming up with our auxiliary equation. F of m is equal to 0. So our auxiliary equation is m cubed minus 3m squared plus 9m plus 13 is equal to 0. Then we are going to solve for the roots of this given cubic equation and verify if whether they are imaginary or not. So there are a lot of ways to solve for the roots of this given equation. We can of course use the rational zero or rational root theorem, where you will take p over q, where p is r rather. P is the set of factors for our constants. So we have plus minus 1 plus minus 13, and for q would be the factors of our leading coefficient plus minus 1. So there are only 4 possibilities that you could try as you take the ratio of the two. But of course, based on the name itself, rational root or rational zero theorem, the roots that will be identified are only rational, or in short, they are real. What if there are roots that are imaginary? That is why, for some cases, the rational root or rational zero theorem may not be the best option. What we can do here is this. Let us proceed to the previous process we did in solving for the roots of equations like this, where we think of test values. Let's say, what if our first root is 1? Let's verify if it will make this entire equation 0. And if it is, then 1 is a root. But if we're going to substitute that, the cube of 1 is 1. Minus 3 times 1 squared is just 1. Plus 9 times 1 plus 13. Let's see if it's equal to 0. You have 1 minus 3 plus 9 plus 13. Obviously, it's not equal to 0. Hence, 1 is not a root. Let's proceed to the next number. Now, some of you might say 2. I would like to use the negative of 1. So starting with the smallest integer in terms of negative, positive, and then the largest integer in terms of negative. You have negative 1 here. Let's try. The cube of negative 1 is negative 1. Then minus 3 times the square of negative 1 is positive 1. Plus 9 times negative 1 plus 13. Let's verify if it's equal to 0. Negative 1 minus 3. That's minus 9 plus 13. Is it equal to 0? This is minus 4 minus 9. Yes, that's correct. That would mean the first root that we have observed is actually minus 1, or the first factor of this given auxiliary equation is m plus 1. Now, once we have verified this, we can now proceed to the use of synthetic division. So we take here 1 minus 3, 9 plus 13, and your first root was negative 1. We're going to do this so that we could transform our cubic equation into an equivalent quadratic equation after the synthetic division. 1 times negative 1 is minus 1. That's minus 4. This is positive 4. That's 13. Minus 13, you will have here 0. This is also an indicator that this value, which is the first root we have observed, is actually true. In short, our next form of the equation, the quadratic one, is m squared minus 4m squared, m plus 13 equal to 0. Now here, we are going to look for the factors for this given quadratic equation to solve for the roots, or we could use the quadratic formula. But I'm going to use here another method just to reintroduce the other process, which is completing the square. Let me move the constant on the other side. So here we have minus 13. I will include here a certain constant and do it on the other side to make the left-hand side a perfect square trinomial. We can do this in this formula. B over 2 square root of a, you take the square of it. Your b is minus 4 divided by 2 square root of 1. So you'll have here negative 2, the square of that. Your c must be 4. So you need to add 4 on both sides of the equation for the completing the square method. m squared minus 4m plus 4 is equal to minus 13 plus 4. Of course, you could always use your quadratic formula, but I'm just going to reintroduce this as one of the options as well. So this would mean you have perfect square trinomial of m minus 2 is equal to minus 9 on the other side. Take the square root of both sides, you have m minus 2 is equal to plus minus the square root of minus 9. Obviously, this shows imaginary, and that is why the rational root or rational zero theorem earlier is not enough, because there are roots that are imaginary. To complete this, you will have m is equal to 2 plus minus the square root of, you have 9 times negative 1. So you have m is equal to 2 plus minus, you have 3, then I, that's the square root of 1. This is your set of imaginary roots, where in this manner, you will have a plus b, plus minus bi, where your a is 2 and your b is 3. We need this because our general form for the general solution of equations, homogeneous differential equations in higher order, with other imaginary roots, are actually in this form. Y is equal to, you will have here e to the power of ax times c sub 1, you have cosine bx plus c sub 2 sine bx. We already have our a and our b here, so you can rewrite it in this manner. E, so that's 2x, c sub 1 cosine of 3x plus c sub 2 sine of 3x. This is for this alone. Take note that earlier we have already identified a real root. So following the combination of real general solution and imaginary roots solution, this is not yet the final result, because your real solution will have this form: y is equal to e to the power, we'll have it c sub 1 e to the power of mx, okay, plus c sub 2 e to the power of second root if there are, until plus until c sub n x to the power, e to the power of m and x. But since we only have a real root, so let's end with this. So you will have here your final solution: c sub 1 e to the power of your real root, which is negative 1. So you have negative x plus, you combine this expression. Take note of the changes here. Earlier, this was c sub 1, this was c sub 2, but since we already use c sub 1 here, let's also change the notations. E to the power of 2x, and you will have here c sub 2 cosine of 3x plus c sub 3 sine of 3x. Or, this is what you will be changing to c sub 1, it's okay. Nevertheless, we will have the same answer. This is our final solution for the given differential equation. Thank you very much for watching.